This Chapter 1 reviews important notions of bond yields and credit spreads, which are critical to your subsequent understanding of the materials covered in this module. More detail on all these notions may be found in our two-part module entitled Bond Fundamentals. For bonds of equal maturities and payment frequencies and trading at par, we can compare coupons directly to determine which bond pays the highest return and which the lowest return. So if I am comparing a 5-year U.S. Treasury note with a 6% coupon to a 5-year note issued by Morgan Guaranty, JP Morgan, with a 6.5% coupon, and finally to a 5-year note issued by Alcatel with a 7% coupon, then assuming all are trading at par, I would be certain that the one with the lowest coupon, i.e. the U.S. Treasury note, offers the lowest return, followed by the JP Morgan note, and followed by the one from Alcatel. It is also customary to describe the JP Morgan note as yielding 50 basis points more than the U.S. Treasury note, or more simply T plus 50, and the Alcatel note as yielding 100 basis points more than the U.S. Treasury note, or T plus 100, since the U.S. Treasury note is generally regarded as the risk-free instrument for any maturity. Note importantly that this comparison is exact only if the three instruments have the same day count convention in addition to having the same payment frequency. Otherwise, an accurate comparison would need to reflect this additional consideration as explained in detail in our modules mentioned above on bond fundamentals. We would be tempted to conclude from the differences in the returns of the three bonds above that the U.S. Treasury note is the one that carries the least risk, from a credit perspective at least, and that Alcatel's is the riskiest. But while this is generally a reasonable starting assumption, we would be well advised to consider also factors of a more technical nature, such as the relative liquidity of each bond, differences in tax treatment, and so on, any and all of which can skew coupons and yields up and down, quite separate from their credit fundamentals. A thorough examination of these technical factors is provided in our module on pricing credit default swaps. If we have reason to believe that these technical factors do not play a significant role in the determination of the coupon on each note, then our earlier statement about the relative credit risk of each note becomes even more reasonable. When two bonds are not trading at par, a comparison of their coupons alone no longer suffices for purposes of comparing their returns. In our modules on bond fundamentals, we discussed in detail the notion of yield to maturity, which attempts to expand the comparison and make it more comprehensive by taking account not only of each bond's coupon, but also of any price discount or premium at which they trade relative to par. In short, you may recall that yield to maturity was defined as that single value for the letter Y that makes the following equation hold true. which states in summary that a bond's price equals the sum of its aggregate cash flows appropriately discounted in each instance. To illustrate a typical application of yield to maturity, assume you are asked to evaluate the risk-reward trade-off of the following 4 5-year notes with semi-annual coupons and which conveniently also have identical day count conventions. So bond A 6% AAA rated US Treasury note trading at par. Bond B, a AA rated JP Morgan note with a 6.4% coupon also trading at par. Bond C, a 5.5% single A rated Alcatel bond trading, however, substantially below par at 92. And finally, bond D, the BBB rated Brazil 7% bond trading at 98. This worksheet YTM should serve as a useful reminder of how we use Excel function rate to derive each bond's yield to maturity. For example, in cell C9, you see how we input each of the bond's principal characteristics in each relevant empty space, but then also remember to multiply by 2 to obtain the annualized yield to maturity, all as taught in the earlier module Bond Fundamentals. The problem that yield to maturity attempts to tackle is that a comparison only of the coupons gives a very misleading impression of each bond's total return if it is held to maturity and if it pays in full. Only the US Treasury note and the JP Morgan note can be compared for purposes of total return on the sole basis of their coupons. The Alcatel bond, despite its lower coupon than the US Treasury notes, yields 145 basis points more if held to maturity, given the 8 percentage points discount from par at which it can be purchased. And the Brazil bond, although priced closer to par than the one from Alcatel, turns out in reality to yield 79 basis points extra when its far higher coupon is taken into account. Note finally in the bottom row, for the 3 non-US Treasury notes, the conventional expression of their yield to maturity as a spread over the yield to maturity of the US Treasury note, given in particular their equal maturities and payment frequencies. We remind you finally of a few characteristics of yield to maturity measures that were covered in detail in the Bond Fundamentals modules before we proceed with the construction of a very simple asset swap. First, yield to maturity is always higher than the coupon for any bond trading below par and lower than its coupon for any bond trading above par. Second, a weakness of yield to maturity that should be obvious from the above formula is that it is based on the discounting of all cash flows over the entire bond's life at a unique annualized discount rate that is held constant across all maturities, whether the risk-free yield curve is very steep or severely inverted or completely flat, A better measure would presumably attempt to recognize the shape of the risk-free curve, but also possibly the so-called term structure of credit spreads, which refers to the tendency of credit spreads to become wider the further out into the future a cash flow occurs. Nonetheless, yield to maturity is used extensively by practitioners because it can be derived quickly, it requires limited data and mathematical skill, and it allows a decently accurate comparison of the potential returns of two bond instruments of comparable maturity, even when their trading prices and coupons vary significantly. This completes this brief summary of bond yields and credit spreads and allows us to move to the description of a simple asset swap in the next chapter.